Good morning, BIS students, grade 9. This is week 7. We'll continue the explanation of the pressure in liquids. As we said before, according to Pascal's theorem, liquids transmit wholly to all points and in all directions any pressure variation they undergo. What do we mean by this? Let's observe this experiment. This 250 grams is placed at this side. We can see that the level of liquid here increases. I'll use this in order to see the measurement of the pressure at different points, as we can see. I'll put another 250 kilograms. As we can see that the pressure at different points also increases, although the pressure is exerted at this point. What if I use this 500 kilograms again? We can see that the pressure is increasing at any point. This is what does Pascal explain in his theorem. Again, liquids transmit wholly to all points and in all directions any pressure variation they undergo. Now, the total pressure exerted at a point. Observe this point A. It's immersed in liquid. The pressure exerted by liquid equals to the density of liquid times gravity times HA, which is the height separating this point from the surface of water. What about the pressure at the surface of liquid? Let's see this simple experiment. Okay, previously I mentioned that the atmospheric pressure here is off. What if the atmospheric pressure is on? You can see that the pressure at the surface of liquid changes from 0 to 103,405 Pascal. So we cannot say that if we are sitting now at home, at shore, whatever, that we are not subjected to any pressure. We are under the action of the atmospheric pressure. What about the inside liquid? Let's take this point as an example. If the atmospheric pressure is off, the pressure exerted at this point is 10,055 Pascal, and the pressure at the surface is 0 Pascal, at the surface of water, of course, or any liquid. But if the atmospheric pressure is taken into consideration, we can see that here it's 103,405 Pascal, and if we add the 10,000 previously 55 Pascal, the answer will be 113,460 Pascal. So as a conclusion, we can say that the total pressure exerted at any point A will be equal to the pressure exerted by liquid plus the atmospheric pressure. The last idea in this chapter will be the hydraulic press. What is the hydraulic press? Hydraulic press is an instrument used to transmit the pressure exerted by a force from one point into another. What does it mean? Do you know the brakes of a car? When we apply brakes on the car, although the force is very small, but this force will be transmitted by means of the oil of the car to the whole points to reach this big surface area where we can stop the car by using a very simple force. So for this two objects to be at equilibrium or surfaces to be at equilibrium, as we know that pressures at the same horizontal level at rest are subject to the same pressure. So we say that P1 equals P2. What does P1 correspond to? Pressure exerted by F1 on S1, which is F1 over S1. What about P2? Pressure exerted by F2 on S2, F2 over S2. So the relation will be, if we are using here weights, W1 over S1 equals W2 over S2, where W equal M times G over S1, M2 times G over S2, which is known as hydraulic press. The concept of the hydraulic press similar to this experiment that we did. As we can see here, that the level of liquid will decrease at this point and increase on the other point. To attain equilibrium, I have to exert a force here, perpendicular to the surface, for the two to be at equilibrium or at the same point. This is the concept of hydraulic press. So this is all what you have to know for now. Again, the total pressure exerted at a point is the sum of the pressure exerted by liquid plus the atmospheric pressure. If an object is at the surface of liquid, the only pressure exerted will be the atmospheric pressure. Study well, stay safe.